Greetings and welcome to another edition of Todd Talk, where we take teaching theory and turn it into teaching practice. In keeping with our theme of 21st century skills, 21st century skills are skills that you can teach in your classroom that transcend the classroom. So they're not necessarily content-based or require memorization, but they actually, in a lot of cases, require hands-on abilities. And some of that we looked at so far is the idea of leadership and be able to, what are ways that you can allow students to, develop as leaders. Another one is public speaking, which is an important skill to have. And there are other skills such as collaboration, critical thinking, things of that nature. So the one that we're going to be talking about today is the idea of problem solving. So problem solving is very valuable for numerous reasons. But one of those reasons is that if you can solve a problem, then you're someone that a company would want to hire, because that's what most work does, is that they have problems and then they solve those problems. Some of those problems are very grand in scale, some are very simple in scale, but they're asking employees to solve problems that don't necessarily fall step by step a certain answer. Sometimes it does. If you're working on an assembly line, you have to assemble that car the exact same way every single time. You have to be consistent with that. So you're solving the problem the same way each time. But in a lot of cases, you're coming up with a solution to a problem that may be, totally outside of the thinking of other people. And so if you have the skill to be able to problem solve, then this is going to be very valuable out in the workforce and in real life, because you'll use this in everything from your schooling to your personal life to your work life, to anything that you're doing. There are going to be moments where you'll have to solve problems. So here's an example of what problem solving can look like.
Oxygen tanks are stirred. Roger that. Hey, we've got a problem here. What did you do? Nothing. I stirred the tanks. Whoa. Hey. This is Houston. Say again, please.
Houston, we have a problem.
Gene, we have a situation brewing with the carbon dioxide.
We had a CO2 filter problem on the lunar module.
5 filters on the limb.
Which were meant for 2 guys for a day and a half. So I told the doctor.
You're already up to 8 on the gauges. Anything over 15, you get impaired judgment, blackouts, the beginnings of brain
Well, I
asphyxia.
suggest you gentlemen invent a way to put a square peg in a round hole. Rapidly.
Okay, people, listen up. People upstairs handed us this one, and we gotta come through. We gotta find a way to make this fit into the hole for this, using nothing but that. Let's get it organized.
Okay, let's build a filter.
The deadly argon gas is literally poisoning the astronauts with every breath in and out.
Heads up, heads up.
And smoking on top
Go. Heads up, people, look out now. What's this? That's what they gotta make.
So what you see here is they literally have a problem. Houston, we have a problem. And they have to figure out a way to get these guys down from outer space, given that their spaceship is damaged. And then there's additional problems that crop up. And the one you see here is they have to take the converter that converts the CO2 to oxygen and find a way to literally take a square peg and fit it into a round hole, using all of the materials that they have in front of them, because those are the materials that the astronauts have. And so this is problem solving at its finest. These are probably physicists, people with multiple degrees, and what they came up with was something that had never been created before, but it solved the problem that they needed. And so how you can teach this in the classroom is you can use what's called the GROW process. The GROW process, as you can see here, starts with a goal. So in this case, the goal was to convert the CO2 converter to oxygen. So figure a way to make those two fit so that they weren't just breathing carbon dioxide, but they were recycling. It was becoming oxygen. So that's the goal. The reality is kind of like the constraints. So what is it that you can and cannot do? So you saw that they threw those boxes on the table. That was all the stuff that was on the spaceship, but they can't take stuff and put it up in space on their ship. They can only use what's available to them. And many times when you're solving a problem, you are given certain constraints as well, things that you can and can't do, whether it be budget, whether it be time, whether it be materials. There's lots of things. So you have to consider this reality. The next is obstacles and options. So this stands for a couple. So obstacles are things we've kind of already talked about. So what is going to prevent you from solving this problem or prevent you from being successful in the solving of this problem? And then how can you overcome those obstacles? Options is, have you looked at several different options to solve the same problem? So many times there will be multiple ideas for how you can solve a problem, and many of them might work, but maybe only one of them is the one that would be the best option, or maybe a couple of them will be really poor options. So you have to weigh your options and to determine which options are going to be good ones and which ones are not going to be good ones. And then lastly is a W is way forward. And this is how are you going to proceed step by step to now solve this problem. And so as you saw in the video, what those guys did was they created the final product, and then they had to go through and tell the people up in space step by step how they would create that themselves and what materials they would need. So the way forward is just a way for you to make sure that not only that you are doing the steps, but that they can be repeated by others as well. If the similar problem comes along, then that problem can be solved. So that's the grow process. Another structure or framework that you can use in the classroom is the one that you see here, which is the engineering design process. The engineering design process has 5 steps to it. So first we ask, and we start with the problem. This is obvious problem solving. And you look at the constraints and you ask all sorts of questions like, what is the problem? What caused the problem? Why is the problem happening? So on and so forth. And that can be very short. That can be very long. It can be developed. It can be very prescribed. It can be constructed by the students themselves. There's lots of options that you can go with there. So then there's the imagination or imagine stage, which is they're brainstorming all sorts of ideas. And this should look messy. Brainstorming is not clean. It's messy. So you can have students come up with dozens and dozens of solutions to the same problem, especially if it's an open-ended one. If it's not open-ended, then there may not be a lot of imagination that's going to be used, which is why an open-ended problem can be much better than a definitive answer. So by giving them, this open-ended, they can imagine all sorts of possibilities. And then they have to weigh these possibilities. They have to figure out which one is going to be best for the purposes of what we're trying to accomplish. 3 is then planning this. So what is it going to look like step by step if you're going to accomplish the solution to this problem? So what do you need to do? What materials are going to be needed? What skills are going to be needed? What work is going to be needed? So this is the actual plan. And then you get into the create part. A lot of times what happens with problem solving is that we start at the create part, where we don't ask questions, we don't imagine, we don't plan, we just jump in and try to figure things out. And a lot of times this results in not so great solutions. And so you want to make sure that students are going through these first 3 steps of asking, imagining, and planning before they actually start to create. So you want to make sure that they've thought about this and they're giving it their best effort. And then the final one is improving. So how can they make the work better? So when they find their final solution, are you giving them a space to reflect upon this? Are you giving them an idea of what it is that they can do to improve it? Or are they talking about possible changes that could take place with the solution to this problem? So that is the engineering design process, and it can be used. It's very popular in STEM, and so it's one that can be applied to most problem solving, especially the more open-ended you get. So important aspect, which I've kind of touched on before, that I want to reiterate with you, is the idea of reflecting. So we tell students it's okay to make mistakes all the time, but we don't necessarily then allow them to make space to make mistakes, or a space to go big and fail. But if they were successful, would have this wonderful solution. But instead, we constrain them and not allow them to try this really great big idea because they're afraid of failure. So we have to give them space to be able to fail and to reflect upon this failure and how they could do it better. An activity that I do with my students is the paper tower challenge. So what I do with students is I give them 20 pieces of paper and I challenge them to build a tower as high as they possibly can. I give them 5 minutes to do that. So I give them a constraint of time, I give them a constraint of materials. And typically what happens is some groups will be somewhat successful, but a lot of groups will fail miserably. Matter of fact, what happens a lot of times is they wait till the last, they keep wanting to add layers, and they get to 4 minutes, 40 seconds, and they add another layer, and the whole thing falls down, and they have nothing. And so, but what we do is we learn from this mistake. So what we do is then I take them back to that engineering design process, and I ask them to actually ask, imagine, and plan before they ever touch those pieces of paper. And I challenge them to make a tower that's taller than the one that they originally made. And 9 times out of 10, students are able to make a tower that's taller because they're using this design process, they're reflecting upon it, they're learning from their mistakes. And this is really important in problem solving. A way you can do this in math class is have students look at some test that they did poorly on, or an activity that they didn't quite get it. Have them reflect upon what did they learn from these mistakes? What did they learn moving forward, or their way forward, or the next time they do this, how are they able to solve this problem? So that's going to be really important. So what it might look like in the classroom is giving them a real world scenario and having them actually solve that problem. This is why I like Model United Nations, because you're looking at problems that are affecting the world and trying to come up with a solution to this problem on a grand scale. And again, there's no one right answer. There's a lot of possible answers. A second thing you might want to do is you might want to have them tackle a problem that can't be solved. So give them something that doesn't have a solution. There is no solution, but still have them work on that and try to come up with a solution, and realizing that they're going to fail. But they'll learn from that failure, or they'll learn through the process of working on that problem how to work on problems. So that's what it might look like in the classroom. So you can do it subject specific, you can do it generally, but teaching students how to solve problems, not just in math class or science class, but in social studies, in gym, in language arts, is going to be very valuable, and it's going to allow your students to be successful in the real world.